Hello guys, this is a homework guide. Okay, so here's your homework for week 3. And I hope you guys understand that I try to give you not as many questions as usually from the homework. Okay, I try to condense the question to not too many, right? Too manageable, right? For example, this whole week, you only have there's not many, really not many, very many questions, less than 30 questions. No, wait, less than 40 questions, by the way. Less than 40 questions for the whole week. It's not a whole lot of questions exercise. The point is not how many questions we do, is how well we understand the subject matter. As much as the centerpiece is the homework, right? And the centerpiece, the lectures and homework, but really the centerpiece is truly to understand the contents. I went in details, great details on the recording. Sometimes certain recording, I do it over and over again because I'm not satisfied with certain things I said, or maybe I could have said better with better examples. So for each hour of recording, I spend double, even 3 times, as much time to prepare for that lesson. So if you watch it once and you get everything, then you can ace the quizzes and ace the homework. If that's the case for you, most likely you do not need to take this class. Or you are truly a genius. If you are either kind, then you should not be in this class. The recordings need to be watched at least once. I would say 3-4 times, 3-5 times, 3 times or 5 times. There's so much content that go in there. Yes, there's a lot of competition, and yes, there's a centerpiece, there's emphasis, but you need to write it down, okay? So before I go to the homework, I'm going to write down a couple of things that I wish you to understand as a guide. And this is the guide actually I wrote for one of the students, right? And this student was telling me that she has, or I don't know, he or she, and this student says, I've been watching the video in the modules, and I even watched extra videos to help me understand. I felt confident going into quiz. For some reason, I still don't do well. And this student did not mention that and then he or she has done homework. And so for that reason, I gave the following advice, right? I gave the following advice. The first one is that, of course, you need to do the homework. Right? You need to watch the video, right? Watch the lessons. You can watch any other lessons, right? Anything you have your hands on, right? Khan Academy or anything, right? Other university professors' lessons, right? Watch the lessons, okay? Take notes, okay? Try to do the question, the same question in the lecture on your own, okay? Sometimes you may like to pause, right? And do it, try to do it by yourself. And sometimes you can, sometimes you may not be able to do it. Okay, you need to go back and forth, right? And sometimes you make a mistake, and then you will realize, oh, this way would not work, even though I thought it might, right? So watch the lesson, take notes, and try to do the same questions in the lectures, in the recorded lectures on your own, okay? In the recorded lectures on your own. And of course, if you have any questions, attend office hours. I have office hours Monday through Thursday, every single day. And the tutor has office hours, right? Watch them, go to those office hours. Those are live office hours, okay? So do that, attend office hours with your questions. Okay, number 3, okay, you may like to read a text or do homework. Do homework. Okay, read a text. Read a textbook. Any textbook on the subject matter is okay. Okay, they're usually written written for reading. They're written for reading, and of course there's a difference in order, and that's fine. If you have any questions, is get to the teachers. Okay. So you watch the lecture, try the question in the lecture themselves, go to office hours to ask questions, or with the questions you have when watching the recorded lectures. Do homework, read a textbook. If you have questions about your homework, you may like to watch the video again, right? If you have questions on homework, okay, watch the recorded lectures again, right? Attend office hours. Attend office hours. So once again, if you can do all of your homework by just watching the lessons once, and you do your homework all at once, and most likely you probably don't need to take this class, okay, if you don't have any questions. And now after you've done all the homework questions, and then you hit the quiz. Okay, you hit the quiz. After quiz, after homework. A lot of the questions are selected from homework and the lectures. Okay, a lot of the questions on quiz are selected on homework and the lectures, lessons. Okay, so you should do quiz the last. And of course, you need to leave enough time, right? You don't want to do the homework. You don't want to do the quiz in the last day, right? You want to do the quiz maybe in between, right? After you do the first round, lessons, homework, and then quiz, right? And the second time, third time. I recommend this way. Of course, each one of you have your own way of learning, your own styles and your own backgrounds. But I hope that whatever you have discovered that works for you, and you need to understand quizzes cover homework and the lectures. Okay, so from that, you should know the order and when you should do the quiz. Okay, so without further ado, after you've done everything, okay, I still recommend, okay, after you've done everything, after everything is done, right? You're done with the homework, you're done with the quiz, you're happy with your quiz score, still summarize. I have tried to summarize during my lesson time, usually at the end of the lesson, because I want to show you how to summarize. But once again, I did the summary. And if you want to be a better student, you want to learn how to summarize yourself. Okay, and that will bring you to the next level of study. Okay, you will be much more proficient at the subject matter you study. I think this is true almost to any subject of, as a student. Any subject you study doesn't have to be math, and I think it should work in, for other subjects as well. So summarize is a very, very important skill to acquire. But anyway, without further ado, let's get to the homework. Okay, let's get to the homework. Okay, So our homework for this week, we have some homework questions from the logarithm and exponential. And in fact, I didn't give you much of exponential calculation. I gave you logarithm straight, right? In the lectures, you see the definition of functions. We very much focus on definitions. For example, the first one, right? The first one is find exact value. I recommend not using a calculator, So for example, in the lesson, we have studied a function, which is actually we studied the function, inverse function, right? Inverse function, which is the function itself. Okay, so let's go back to our context, right? So this is a lecture you have watched, right? And in this lesson, okay, so let me make it 175% font. So this way you can see the negative exponents. So this inverse function is log base 3 of x, right? And the function is f of x, and that's 3 to the power x, right? So we have these two, this pair, right? And we talk about we have in that lesson, we talk about finding inverse, right? Swapping, domain range change, and the relationship between logarithm and exponential, right? So basically, these two functions are inverse to each other. We have a log base 3 of something, right? We call it omega, and equals to triangle, right? I just pick up arbitrarily two symbols. And these are at the essence, right? At the essence of this relationship. Okay. That equals to omega. The general form, okay, of course, this is the special form when we study base 3, right? The general form, okay, I believe you have studied before, right? Most likely you study the general form. It's just base has changed to be, any base. And of course, we have imposed a condition for that base. That base must be greater than 0 and not equals to 1. Right, so under this condition, we have the general form of logarithm and exponential function. And we establish functions in that, you see, in that context, right? In that context. So in this regard, if you look at the first question, right? And you need to decide, right? What is log base 3 of 1 is equal to? You just need to give an answer, right? You just need to give an answer. You can apply this definition, or you can make a connection between these, right? We know this notation, but we just save that notation, right? We kind of save that notation. Log base 3x, so base 3 and x is 1. So this is basically where we're working with. We kind of save that piece, right? We kind of omit that piece. Does that make sense? So this is just shorten the question, but in relationship to the question we studied in the lesson, it's about function. We're trying to evaluate. We know the input, we're trying to find the output, right? We know there's exactly one output if the input is in the domain. Does that make sense? We don't need to write this, and you don't need to write this. I just want to make that connection. Okay? So we're interested in, right? So we can bring up this answer, this question over here, right? So log base 3 omega is 1, and we're looking for what should be in the triangle, right? So we're going to identify that number, and that number is going to be, this number is going to be in the place of triangle, right? And triangle, in the place of triangle is a question mark. So this is a question mark, right? Omega is 1. So this is 1. So what number power 3 equals 1? Then, well, we know that's going to be 0, right? So that's going to be 0. Okay. So how are you going to express your work, right? How are you going to express your work? When you express your work, really you don't need to do anything like what I just shown right here. You don't need to show the rest of them. Okay, I just did it. Okay, in the future and even at present time, if you can do this correctly, you are good. You're good. Okay, you don't need to give these other reasons because you probably have done that either in your head or on your scratch paper. Okay, so this is how much work you really need to show. I hope that makes sense. Okay, now let's look at number 2. Okay, we're not going to do everyone. We're going to just do selected, right? Selected a number of questions. So say, for example, in this case, right? You can show this much work, right? Because by this time, you know that you're looking for the power, right? What number power 3, right? Log base 3 of 27 is looking for that number, that power 3 equals to 7. And of course, this is 27. And you can see numerous examples that we have done when we did the graphing. Okay, so I really just have selected some questions in the process of graphing the pictures, right? We graphed 3 to the power x, log base 3x, right? We made those tables. You can see the examples I have chosen mostly are from those tables. Okay, mostly are from those tables. And of course, there's some other interesting ones, such as number 4, right? Number 4, we have log base 3 of square root of 3. What would that be, right? If we realize that root 3, square root of 3 is 3 raised to the power of half, then the answer is just half. The answer is half, right? Let's do a couple more. Number 6. You may like to, at this point, because number 6 is a little bit challenging, okay? Log base 3, you may like to pause the video right now and try to do this question on your own. Okay, try that. So I leave that for you. If you want to pause, I did recommend you to pause here, right? So log base 3 equals to, right? The denominator is 3 in the square root. So I can write it 3 raised to the power of half. Not 1/2, sorry, 1/2. So I find my 2 under 1. And the next step, right? If you want to show nice work, and this will be one version of it, right? This will be one version. And then on this step, I'm going to write 3 to the power half, and I make it a negative exponent, right? So what did I use here? What I use is b raised to the power of a negative n is equals to 1/b to the power of n. You don't need to show this to the reader. You can just write it down like that. That will be fine. And next, we're almost there. We got the answer, right? The answer is -1/2. That's it. Okay. Number seven. Okay, number seven. Number seven, actually, I'm not going to give you the answer. Okay, I want to tell you where this step showed up. Okay, is at the time when in the lesson talking about exponential function and logarithm function base 3, right? When we are working with, what did we work with? We worked with f composite f inverse. Okay, we know that's equals to x. And we also worked with f inverse composite f of x that equals x. And we know that this first x, okay, even though they're both are called x's, they're actually just mere placeholder. And this x is from the domain of f inverse. Okay, then you need to think about what is the domain of f inverse in this case, right? What's the domain of f inverse? You need to know the domain and range. And this other x, right? This x is from the domain of f. Okay, I wish you guys to go back to watch that part of the video. And in that part, you're going to see that for yourself. You're going to see that for yourself. Okay. And I do want to give you another source. Okay, another source for getting the same conclusion, which is right here. Okay, right from here. Okay, another source, which is most likely you have learned this from your previous. Okay, so another perspective. Another perspective. Another perspective of this is that you see 3 to the power of a triangle is omega. Okay, or you can call it baloney, right? We can call it baloney right here. And triangle is equals to log base 3 omega. So we simply replace the triangle by it. Okay. Omega is from the domain of log base 3. So omega must be positive numbers. So omega must be positive numbers. But in this format, omega can be any positive numbers. You see, omega is from the domain. Is from the domain of what? Of log base 3. Okay. Log base 3 omega, which is omega is positive numbers. So this statement is true. This statement is true for any positive number. So now you reflect on question number 7. I think you would have an answer. You will have an answer. Okay. So there are two sources. Okay. Now let's look at the question number 2. Okay, this set of question is about common log. We did not do common log in our lessons, but I kind of expect you guys have remember that, or you know that you can review from the textbook. And here I'm going to give you a review. Okay, I'm going to give you a review. For base 10, okay, when the base is 10, when base is 10, okay, and we got a common log. Okay, and base 10 is certainly larger than 0, not equals to 1, so we no longer need this condition. So we have base 10 here. So this will be 10. And when the base is 10, we use a default notation, log. So whenever we write log, log, without indicating the base, by default, it is considered base 10, okay? On your calculator has a button log, right? Some of you have log, some of you have ln, natural log. But most of calculator has log, fewer calculator has ln, and that log meant base 10. Okay, so you see it's very similar to base 3 and base 2 and base E. It's just in different setting. For example, you can apply the definition, right? The related function, right? The function, which is 10 to the power of x, right? And its inverse, f inverse, is log x. Okay, so these are functions that are inverse to each other. All the properties we had for the other pairs, right? Base 2, base 3, base E, they are all similar. They are all similar. Okay. So now I would like to ask you guys a question. If I graph these two pictures, along with base 2, base 3, and base ln, base E, where do you think they will be positioned? Okay, you may like to pause the video right now. Okay, I'm gonna bring the picture back here, and I want you guys to pause, right, and try to plot those points and see what are you getting. Okay, you know what I'm getting, right? I'm gonna get my my recordings, no, my exponential log function here, right? We had a bunch of curves, right? We've done a bunch of curves. Those curves we have done, I'm going to bring them. Let's see, where are all the curves? Where are all the curves? Right here, right there. All of them, right? All of them. So where are they going to be? Where are they going to be? Right, so I'm going to copy this. Okay. If I graph these two in this picture, where do you think 10 to the power x will show up? Where would it show up? And where will log x show up? Right, where will log x show up? Right? I'm going to leave that question for you to think about. It's not a part of homework, but it will be it's something as a student you want to think about it. Okay, plot points. Okay, in this picture, plot points, right? So I'm going to give you some examples to plot the points, and I'm not going to complete the question for you because I expect you to take the initiative. Okay, to take the initiative, right? So input x, right? So 10 to the power x. And the input output, right? Input, comma, output. Another table. And we're going to plot the points. We still have input, and this time is log x, and input output, right? So we can do input. We can write input. Okay, output is that, and that input, right? And you would also think about domain and range, right? Domain and range. Domain, right? Range. Not going to give you the answer at the moment. Okay, you need to think about it. Domain and range. And for the other ones, is also you need to think about domain and range. Domain and range. Okay. Domain and range. There. Okay. right? And how to find inverse, how do you get one from the other, right? And we already have the basic relationship right here, right? So that's basically the inverse relationship. Anyway, so I'm going to give you a couple inputs. Okay, the input I'm going to give you here is -1, 0, 1, 2. Okay, we don't need too many points. Okay, I want to make it keep it simpler for you. And the input I give you 1/10 for this one, right? 1, 10, and 100. Okay, and you are to calculate. In the process, you're going to find the answers for number 2. All right, so I gave you some questions, right, as a homework guide, and I hope this will make you think, right? If you finish these pair, 10 to the power x and the log x, you have done, we have done 4 pairs. Okay, 4 pairs give us enough insight about exponential function and logarithm function in terms of domain range, increasing, decreasing, 1-to-1, increasing, decreasing. You know, these properties will become very clear to us. And also, we have some points in our mind. We have some points in our mind. Okay. But anyway, so that's what I will leave you at. And I trust you guys will be able to get them done. And the next part I'd like to discuss is the trig function, okay, which is number 3. We have discussed much in this week. Mainly, we really want to understand the definition, and which is the 3 pillars. I would say A, R, D, right? So besides the standard position, right? What is A? A is about angle measurement. Angle measurement, right? Positive angle is counterclockwise. And the negative angle is clockwise, right? Clockwise. So that's basic rules. We already understand. I already understand. And R is a reference angle. Reference angle. Okay, so what is reference angle? The positive acute angle between terminal and x-axis. Okay, and D, of course, will be the 6th definition. Okay, D is the 6th definition, right? And by this time, I think we are very familiar with these 6 definitions. So let me put them there, right? 6 definitions, right? Sine, how sine is defined, sine of A and the cosine A, right? Tangent A, cotangent A, COTA, right? Cosecant, right? Secant. Wait, I'm going to use uppercase. Okay, wait. There. Okay. Secant. Okay, so these 6 functions, and they each have a definition. But before the definition is given, there's a point. There's a statement, right? There's a statement. What is that statement? We choose a point, right? We choose a point. X comma Y is on what? Is on the terminal side. On the terminal side, right? Other than the origin. So this angle is measured. It doesn't matter how it's measured, what units be measured with. this point is on terminal sides other than the origin. And with that, we have decided that, of course, we also have an r, right? R is equals to square root of x squared plus y squared, right? So once we know x, y, and then we in turn, we know the r, and all these functions are defined. So sine would be y over r, right? Cosine would be x over r, right? And then we talked about how we can, why we introduce unit circle, right? And then we discussed the special angles, right? And all that discussion we have done this week, right? But the centerpiece is really the definition. Okay, so this is r over y, and this is going to be x under, okay? R over x, R over x. Okay, we have the definition. So these are the three pillars of trigonometry. These are the three pillars of trigonometry, A, R, D. Okay, and of course, angle measured from standard position. Okay, so that's it. Right, this is the centerpiece. Now, so let's see how we go about each one of these questions. How do we go about each one of these questions? Okay, so I'm going to take an example, how I wish you do these questions to understand the three pillar. Okay, and I used to see students, they come in, they have all the points on that unit circle memorized, and they in most of the cases they can use it properly. Okay, and sometimes of course there are some students they only memorize it, they don't know how to use it. They can use it properly. However, when I give them a non-special angle, okay, it's a non-special angle as the reference angle, and they're lost. Why do we have this kind of phenomena? It's because the student only remembered those points without really understand how we got those points. Okay, we got those points by applying the definition, by applying ARD. And so that is at the centerpiece. So this is really the center, not those points. I know if you don't understand, how do you memorize them, right? How do you memorize them? It's very, very difficult to memorize. So I'm going to pick up a couple of questions to show you how I wish you do these questions. Okay, how I wish these questions to be done. Okay, to be done. I basically want you to go through the whole process. Okay, go through the whole process. Okay, say take the example of, let's take an example, right? Number 3 from your homework. Let's take this one, cosine 2 pi over 3. Okay, cosine 2 pi over 3. Cosine 2 pi over 3. What I wish you to do, okay, what I wish you to do, I wish you to go about, to think about all these three elements. The angle is a positive angle, right? So you first look at 2 pi over 3, and then you know this is a positive angle, okay? So it's a positive angle. In your mind, okay, you know, it is measured counterclockwise. Okay, counterclockwise. And of course, if you need to, you can convert that to a degree if that helps you. Okay, and for added benefit, you may like to see, okay, how I'm going to measure the angle. How am I going to measure the angle, right? If you get a degree, you're going to get 120 degrees. 120 degree is 90 degree plus 30 degree. So that way you will have some idea as how to measure, right? So I'm gonna bring the coordinates into our study. Okay, we're gonna bring that coordinate into our study. And of course we can, yes, you can use that circle. You can use that circle. Okay, I'm not against it, but let's see if you do it in the most, in a way that it really utilize the definition. Okay, how that could be done and how that could enhance your overall understanding of the centerpiece. Okay, so I'm going to just make some adjustment to the picture. Okay, make adjustment to the picture. And you are aware of the choice of measuring the angle, right? The way we measure the angle is by counterclockwise. And there is a standard position, right? There's a standard position. So I'm going to put the standard position in place, and we decide to use the pink, right? We decide to use the pink and there, right? That's our standard position. So I want this to go through your head when you see 2 pi over 3, then you know, oh, I'm going to measure from the standard position, passing 90 degree, and then we get over there, that's a 30 degree, right? So this angle is 2 pi over 4, or 2 pi over 3. Okay, so I have that. I want that to flush, even have a flush in your head. Okay, so this is 2 pi over 3. Okay, and then I want you to think of the reference angle. The reference angle is R, which is, in this case, the reference angle is pi over 3. The reference angle is pi over 3, right? We thought of the R, we thought of the A, and we thought of the R, right? Now, so how we are going to calculate, we're looking for cosine 2 pi over 3, right? A cosine 2 pi over 3. So then we can do this on unit circle. We can do this on unit circle, right? So I'm going to draw the unit circle. Okay, I'll draw the unit circle. Right, so we have our unit circle right there, right? And then here we go. And then we will, we have the reference angle here. And then if you like to relate to the degrees, that will be fine, right? So this triangle, there's a 60 degree, 30 degree, or this is pi over 3, this is pi over 6. So this triangle is, if you know, we know this triangle, we study this triangle, right? So we will know this piece, okay? This piece is the red. That is the negative half. That's what I want you to visualize and write it down for yourself. And the next piece here, okay. No, this should be blue. Okay. I promise you, I try to make that color coordination to help us understand, right? The consistency. So the blue piece, right? The blue piece, that blue height is going to be √3 over 2. Okay. root 3 over 2, right? For that special triangle. And if you need to do the Pythagorean theorem, go ahead to do the Pythagorean theorem, okay? And this is, of course, the radius is 1. Radius is 1. So that point, this point is the red and blue, the red and blue. Okay, so I want you guys to have this go through your head, if that's not too much to ask for. Okay, the whole process of ARD. This is what I wish you do for these 24 questions. They're not too many. Okay, and I try to give you questions, not too many questions. If you do each one of them with such thoughtfulness and mindfulness and go through the steps instead of just getting the quick answer, and I assure you that you're going to be so much better at this subject matter in very short period of time. Okay, because I have practiced this, and then I realized really ARD is the centerpiece. Okay, all the other tricks, I know you have learned tricks. Some of you learn tricks of this kind, that kind. Forget about those tricks other people teach you. Get to the center of this issue, okay? Once you master ARD, you will create your own tricks, okay? You will have your own tricks, okay? And your own trick will not confuse you, okay? Your own tricks will not confuse you, okay? So for now, try for some time not to use those tricks you may or may not be certain about, okay? Now you're going to mark that point, right? That's what's x. X is the half, right? That's a cosine. And root 3 over 2 is the blue, is the sine. You see? So this is what I meant. These special angles are serving our centerpiece, which is the 3 pillars, ARD. Okay, 3 pillars, which is ARD. Okay, I hope this helps you. Okay, so let's do another question. So before we do the other question, of course, we're gonna conclude this question, and that the answer will be cosine, right? And also how you write it, right? Cosine 2 pi over 3, 2 pi over 3, right? So the input and the function on the input produces an output, and that output is -1/2, -1/2, right? In the process, okay, I'm asking you, please allow yourself time. Be patient with yourself. Go through this process. If you go through this process for these questions, and you will be the master, okay? You'll be the master of this subject, okay? And that's how easy it comes by, okay? All right, so let's do another question, okay, which is a negative angle. Okay, this other question I'm going to select, which I'm also going to show you how I wish you do this question. Okay, still ARD. Okay, let those thoughts go through your head. Okay, let those thoughts go through your head. This is sine. The question I select is sine -5 pi over 6. 5 pi over 4, sorry. 5 pi over 4. Okay. We see negative angles. So the angle will be measured from the standard position clockwise. Boom, right there. So the terminal is going to be right here. Okay, so this angle, right? So you let this A go through your mind, right? 5 pi over 4. And of course, that's a negative. Negative 5 pi over 4. There. Okay. And what is the reference angle? Right there, right? The reference angle is right there. 45 degrees or pi over 4, right? So the reference angle is pi over 4. Pi over 4 is a reference angle. It's a positive acute angle between terminal and x-axis. See? The definition flow into your mind. So we just use it. We use it several times, and then we'll be the master of ARD, right? And then with ARD, let me tell you, you will be invincible, because I will show you how you can use ARD and to support you, so you will eventually be invincible. You can solve any questions, any problems. Okay. All right, special or non-special angles. Okay, so without further ado, so we got this, and next we pick a point, right? So we're touching the definition, right? Definition. We pick a point at the intersection of terminal and the unit circle. And this point is marked as what? X comma Y, right? X comma Y. What is the X? The X is the red, right? The X is red. Whoops, why did you give me blue? Okay. The Y is the blue. Okay, the X is the red, right? And this is isosceles. So this point, the red is negative root 2 over 2, and the blue is root 2 over 2. So the point and this point, right? This point is going to be marked as the negative root 2 over 2, and the blue is root 2 over 2. Okay. And now we can tell the reader, what does this equal to? Sine of this angle equals to what? Root 2 over 2, right? Root 2 over 2. Sine is the Y, right? So this is the whole process I wish you guys to go through. For every one of these functions, just use the ARD repetitively. Okay, use ARD repetitively, so that eventually you'll be a natural to do these things. Okay. Let's see. Do we have any other questions? I think we're fine, don't we? I think we're good. I don't know how much time has passed. But anyway, if you have any further questions, okay, so please don't hesitate. And wait a second, okay, let me see if there's possibly any questions from last week's quiz. Okay, I think there might be some question from last week's quiz. So here, I'm just going to take a look at the quiz last week, right? And give you a closure, give you a solution. Okay, quiz question last week. Okay, this will be quiz number 4. Okay, quiz number 4. Quiz number 4. The third question. Question number 3. Question number 3. question number 3. Okay. In this question, we are discussing the domain and the function f of x equals to x squared. Okay, equals x squared, where x is less than 0. So the domain is imposed on. The domain is imposed on, right? So for example, if we don't have this imposed condition, this function doesn't have inverse. With that condition, this function does. And what will be its inverse? Okay. Its inverse, this is addressed in the homework guide last week. Okay, this was addressed in the homework guide last week. But here, I like to go over it again, just in case you have issues, okay? So what is the inverse? Well, first of all, when you look at this function, right? The domain is a negative number, but x, the range is x squared larger than 0, larger than 0. Okay, so that is to say the domain. Okay, let's write it this way. Okay, so if I write y equals to x squared, right? I would say x has to be, right? X is gonna be belongs to negative number, right? So it's from negative infinity to 0, right? And y is going to belongs to 0 to positive infinity, right? When we are trying inverse, when we try to find inverse, step 1, we swap x, y, right? So we swap x, y. After we swap x, y, we end up with x equals to y squared. And this swap, as we mentioned earlier, will cause the domain and range swap, right? The former x that's in this interval, now y is in this interval. So this interval now is for y. Okay? And the former y belong to this interval. This time it's going to be x belong to this interval. Okay. You got it? That's what swap means. So the swap is not merely the symbols of swap. It also implied the interval that they are from, right? Is swapped. Is swapped. So you can see y is negative. Y is negative. X is positive. Okay. Step 2. Step 2, we're going to solve for y. Solve for y. How do we solve for y from here? Right, with all of these. Okay, I'm going to just bring these along. Okay, excuse me. So we're going to take a square root. We're going to take square root. Can we take square root? Of course we can. Right? X is positive, right? X is positive, belongs to 0 to infinity. On the left-hand side, we can take square root. On the right-hand side, what do we have? The square root of y, y squared, right? Why did it get here? Oh, okay. Sorry. So this is going to be equals to absolute value of y. Okay. Remember, y is negative. Since y is negative, right? Y is negative. So the absolute value of y, the absolute value of a negative number is its opposite. It's negative y. Okay? The absolute value of a negative number is its opposite. Therefore, from here, we will get absolute value of y becomes negative y. And then we can isolate y. What do we get for y? Well, that's going to be negative of root x. That equals to y. Okay, so as a result, right? And of course, if we usually like to write it the other way. So y equals to negative root of x. Okay, so now look at the question number 3. And I think I will open the solution to the quiz later. Okay. But anyway, let us, you know, I hope this will give you some ideas, right? And now this will still come with us, right? This still come with us. There. And that's a domain. That's a domain. And that's the inverse. So inverse function, in this case, we have found it. We found it, right? That is negative square root of x with domain positive, right? X is positive. So that's the inverse function. That's the inverse function, okay? But anyway, so let's look at any other questions that we had an issue with. I don't think so. Okay, I think, yeah, I think we're good. I think we're good, okay? Unless there's a report of any issues, and I'll be happy to you know, to help out. Okay, I show up in my office hours. Okay, and I'm looking at quiz number 5. I haven't seen anything that's reported to me. Oh, the even odd function. Yes, the even odd function. Okay, one more question. The even odd question. Okay. Maybe I will make another recording. Okay. Anyway, I think I'll make another recording. I know the question. I don't want to make this too long. Okay. Thank you for watching. Until next time.